Right, so we'll move on to the next radio, which is a Fidelity 2000. So it's a Cybernet 134, so same as a Rotel 240, but with the better speaker. So you get all the performance of the Rotel 240. And what I find bizarre is I see these selling for 15 quid on eBay, and I see Rotel's 240 selling for 100 quid. And this has got the better speaker. Never mind. So, this has been 80 channeled in the past. This is from a dealer in Sheffield. He's reversed all the junk out of it. I think some of it's, I think he's giving me the ribbon cable. And it's transmitting, it's receiving, but there's no transmitted audio. So he can't get to the bottom of there not being any transmitted audio, which is why it's come here. We know we're going to have to take all the lids off. Trouble was, because it was knackered with the 80 channel mod, he wasn't able to test it before he put it back to standard, so it's difficult to determine whether he's generated the fault or whether it was there or what. Bigger speaker. So I'll have a quick look on this board. I'm sure there's nothing I'm going to spot. There's a potential dry joint here, but it's nothing to do with transmitted audio. Oh yeah. Mid-block split and EEPROM fitted by somebody at Birmingham. 12th of August 1995. I want to put my name to it. Right open for prosecution. Right. I think we'll power it up and see if we've got PA working. I can see 4 wires connected to the microphone socket. Get it on the test set. We usually have a little stub to power these up, don't we? And we'll plug our PA speaker into the PA socket. Because this tests a lot of the functionality of the, of course it does, of the microphone circuits and that. So we want our standard Cybernet microphone. Switch on, select PA, testing 1, 2, and we have nothing. Switch it to, let's put picture in picture on, switch it back to CB, going to transmit. There we have it doing more than 3 watts. Switch our monitor receiver on. One, two, voila, and there's no transmitted audio, as he says. So with no audio in PA, with no audio in CB. So let's have a few pokes around for a start. So the mic gain control can of course play up. So let's put my finger on. So we'll go into PA mode. Put volume on full. Put mic gain to full. And there's absolutely nothing happening. Go around the audio IC. Pin 1, 2, 3, 1, 2, 3, 4, 5. I think that's pin 5. Or is it from the other end? 1, 2, 3, 4, 5. Pin 6. So we've got very hot audio on pin 6. Now the chip here plays a part. Got nothing there. Right, so we know we've got the audio IC doing its stuff. We've had times with dodgy power mics which have blown up the audio stages. That's always a possibility, and that IC can be killed, but usually it's going to respond to me buzzing that through my finger. So I'll pause the video and dig a circuit out. So here's a bit from the redrawn version of the circuit diagram. There's pin 6, and it comes from capacitor 96. And it really comes from transistor 13, which of course is unlucky for some. So what could happen? Well, there don't seem to be any nasty electrolytic capacitors that could drag that down. So if it's had a dodgy power mic on it, that could have been killed. I think that's part of the same thing as well. So I think the first thing to do is to poke around transistor 13. That happens to just be there. It's set still on. No problem there, is there? So we should have capacitor 91. If we can find capacitor 91, we should have audio both sides of that. That's going to be fun to find. Looking at the normal circuit rather than the redrawn circuit and dropping things on the floor, like Mr. Chippy's service cell I should have taken back. So we were at transistor 13. So I thought we'll just take this a bit further and see whether we've got anything, because the mic comes up to 0.22, and so we've got an audio path across there. So you should be able to buzz it through with transistor 15's collector and transistor 22's collector. So let's see if we can find those transistors. So 0.22, trying to find it on the other side to, whoops, another art. So I've got nothing when I touch 0.22, but where is it? We've got that transistor. There, isn't it? It goes there. So is the track broken? I'll turn the set off for this one. The track looks blown apart. So let's put a piece of wire in. Probably put mains up the connector. So I'll just suck this solder away. No wonder you can't find this. Nothing to see here, folks. Push it back on. Testing. 1, 2, 1, 2. So back to the squirky diagram. So this comes up from the microphone socket. The mic gain control is going to be there. So from the mic gain control, it comes up to 0.22. And so we started to check pin 6. We found it was on the base of the transistor. We found it was on the collector of 15. We found it was on the collector of 22. So all you've got between there and there is printed circuit board, and there you are, there's the fault. So no wonder he couldn't find it. No, it's nothing he's done. It's been blown up by some numpty, hasn't it? Right, we'll go through the set. He's probably done everything else. Alright, select channel. Let's go back to CB. Check it with our monitor receiver. Testing 1, 2. 1, 2, 1, 2. Yeah. So we'll turn that off now. Right, VCO. Still take me half an hour to do that. You've got to start printing off bigger diagrams and that. If I had an A0 printer, you know, but I used to, when I worked at Nottingham Radio, we got these A0 circuit diagrams of Maxon PM150 radios, but trying to fold them around is also a faff. Right, so it should now be a normal tune-up, and he's probably done this anyway. So now then, David wanted to know, for checking the VCO, so resistor 4 there is resistor 4. So I'm going to zoom in on it. So we've got it just here. So look, there's a link. There's a horizontal resistor 118, and resistor 4 is this 10k one against the side of the chassis. So we're monitoring the far side of it. So now you know where it is. We'll just come out on the zoom. And then we can include the meter. I can't remember, it's supposed to be 3 or 4 volts. Okay, so what we should have is exactly what it says here. Set the unit to receive mode. Select the channel selector to channel 40, which we're on. No, we're not. We're on 20. No, we're not getting the wrong voltages. Test point 1 is resistor 4, as I showed you. We would have 4 volts. And on receive, it's the coil there, which he's already set. And then you set the radio into transmit mode. And you should have 4 volts. We've got 4.3, so I will just adjust, there's some clumsy English, the red trimmer. It's all very, very slightest adjustment, and it's, there you are, receive, transmit. And then we go to channel 1, and we check. I haven't bothered printing this, it's between something like 1.8 and 2.3, so we've got 2.22 on receive, and we've got 2.27 on transmit. So there you go, that's your VCO. So it's done on channel 40 for 4 volts, and then you pop it on channel 1 just to verify that it's somewhere around 1.8, 2.3, something like that. Resistor 4 is the test point. Right, we'll put the meter away. I'm sure this is going to be spot on, but at the end of the day, I'm going to make sure it's right. So it was 4 volts plus 4.3 volts. It's now 4 volts plus 4 volts. So I may as well look at the frequency right now. 27, and we're on channel 1, it should be 20, sorry, there we are, 20, 27, 79098. We'll just pop that up a bit. I'll just do it a little bit short because I think we're still warming up on the test set. Oh no, I'll do it right and then we'll verify it later. 79. (79126) will do me. While I'm at it, we'll set the signal generator to the correct frequency. So we're ready. Okay, so we'll unplug the PA speaker and we'll plug in the test instrument jack, just like that. So we're doing, I've got in 4.4. Have a look on channel 1. .4, channel 40, 4.3. And transmit current on channel 20. 1.175, which is very good for that power level. Okay, I'm going to run through, I'm not showing you that meter, run through this transmitter. That's definitely the peak, definitely the peak, definitely the peak. So we need to get the other tools. And maximise these if we can find the right tool. That's at maximum. It's just spinning round. Are we playing that game again where I'm going to have to release it with an Allen key? We've even got one on here. That's all the yellow tool from this kit. That's at maximum, which it shouldn't be. That's at maximum, which is fair enough. Yeah, so the whole thing's at maximum, which it shouldn't be. So 4.4 watts is what you need to generate to be able to do the balance properly. So we're going to adjust this to the right so that it just starts to move. So we know we've got the tuning point, and we're going to turn this one to the left. The service manual says to 3.8 watts, but you are entitled to 4. So we'll drop that to 4, and that should balance. So we've got 4 watts on channel 20, we've got 4 watts on channel 40, and we've got 4 watts on channel 1. don't often work as quickly as that and easily. That's why it's capable of doing more than 4 watts, not so you go over the limit, but so it will balance. Right, so that's now 4 watts. Low power on the back on these. 450 milliwatts. Drop out a fraction. And our new transmit current in full power is 1.097. Deviation, I want this ALC one to be in the centre, which it is, and then with a deviation one to 2.2 to 2.5. Wallow. Right. I can understand that being high because of it not having transmitted audio. Wallow. It is 7 kilohertz. Wallow is 2.5. So it was 7 kilohertz. I'm going to just verify with the test set behind me, just in case my Marconi one is playing up on its deviation meter, which it sometimes does. It needs the capacitors doing, but I'm not doing it. Ooh, ah. So, just check with the test set on the bench behind. Wow, it's a little bit high. Wow. Good. It's already 7:30. It's scratchy corner time, so I need to get through this quickly so we can do a scratchy corner test today. Or it might stop me reviewing an old magazine on Monday. So I want the meter on the front to read something sensible. Let's put that down as 2.2 to 2.5 kilohertz. So meter on the front. Bangs across to 5, and we want it to read 4. Meter lamp's working. Switches are working, potentiometers are working, sockets are working, PA is working. Move on to receive. Just going to double check because RF gain may not, might gain may not have been full. Wallow. 1 2 1 2 1 2. I think he's right. 1 2 wallow 1. Right. RF gain full. Let's go over to. We'll look at this how it is first. The answer is very good. 0.32. 0.28. 0.88. Squelch. 300 microvolts. Threshold. .66. 100 microvolts, see where the S meter is. Bang on the 9. So let's see if we can just get a bit more out of it. Though it's working absolutely fantastic, we'll just go to our oscilloscope, check the detector. Hardly anything there. Pop that down to about 4 dB, so we're not saturating the receiver, and show you the Cybernet meter. Bigger signal for these. There's one down there somewhere. If that's made any difference, I'll be surprised. So for 12 dB, we've now got, I'm on the wrong scale, for 12 dB, got 0.24. 10 dB, 0.21. For 20 dB, 0.6. Now I want 100 microvolts for full squelch. Which I now have. And threshold, we'll see what it is. .55. What a fabulous set. See where S9 is now. Slightly generous. We're all done. Wrong way. Right way. Unplug speaker. Sounds alright. Put the screws back. You'll notice this had the extra receive circuit, which most Cybernet 134s don't, but you only get in the Rotel 240, some Harvard 420Ms, the York 863 and the Harrier CBX, to name most of them. And yet, as I say, I see these go for 15 quid, and I see Rotel 240s going for 100 quid. It's the same set, except this works better. Great! So we'll take the test gear off, take the smouldering bat off, plug the aerial in, which is the Antron 99. And one Anna Roger. You're joking, Mr. 21. Well, that's got nothing to say for itself, but that's how it is out here. Good. Suits me. Alright, we'll get this scratchy corner tested with Mr. Chippy. Thanks for watching. Nice bit of fault finding and with a positive result.